Hi, everybody. Today we're doing P.8, which is to write variable expressions for geometric sequences. The first thing I want to mention is that you want to be able to recognize a geometric sequence when you see it, because in this particular case, we know they're all geometric, but you want to be able to tell the difference between an arithmetic and a geometric. Anyway, here it is. Um, and this time it says that it is definitely a geometric sequence because we have to write it as a geometric sequence. Um, the difference between 1 and 2 is 1, and the difference between 2 and 4 is 2. And so the difference is changing, and that's how you can tell if you have a geometric sequence. If you have an arithmetic sequence, the difference between the terms never changes. It's always the same difference, or in some people would consider this to be the slope. Well, the slope is changing in this case, and it's getting steeper and steeper. One way to describe it, sorry, is that instead of these being points on a line, 1, 1, 1, 2, 1, 4, they're actually points on an exponential curve. And this is a geometric growth. One thing that happens with populations, for example, is that they follow geometric growth patterns. More information than you probably wanted. So let's get to the meat of it. First of all, the first term goes here. Your first term goes there. And the reason that that's the case is because we're always going to be multiplying this by 1. And this 1 comes from the fact that we're going to take a thing, something to a power of 0. Anything to the 0 power is always 1, whether it's a negative, a positive, even 0 to the 0 power is 1. And I do mean literally anything like this. This could be a times n times y times t to the 0 power equals 1. This is always the case. And when we get to the exponentials, I'll teach you why that's the case. If you really want to learn about why this is true, take a look in the exponential section, and I promise I'll explain it and you'll understand it fine. For now, just realize that we're starting with n equal to 1 in our sequence. And since we're taking 1 minus 1, we're taking something to the 0 power. Now, to find out what it is, we have to figure out what our multiplier is. Well, clearly, we multiplied by 2. And then we multiplied that term by 2 again. And what's happening is our multiplier is 2 and our first term is 1. So we're just going to put in the 1. We get to it. How am I going to do this? Oh, there we go. Okay, so 1 and our multiplier is 2. And then if you want to see this, 2 to the 0 power is 1. 1 times 1 is 1. 2 to the first power is 2. 2 times 1 is 2. And finally, 2 to the second power is 4. And 1 times 4 is 4. So I can check it that way. I know that's way more information than you wanted. So watch out for negatives and watch out for alternating negatives. We got to watch for those too. Now this one is 1, 3, 9. So what's happening this time is we're multiplying by 3 over and over again. So we start out with our first term, 1, and we're taking 3 to a power. So hopefully that's clear. In this case, we're dealing with negative, 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 negative. It's not alternating. If we were taking a power, a negative to a power, it would alternate negative and positive because even powers like negative, negative 2 to the second power is positive 4, which is why they would alternate. But in this particular case, they're just negative, 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 which is why our a to the n is negative 14. That's our first term. And what are we multiplying by each time? We're multiplying by 2, aren't we? Multiplying by 2. So our multiplier is 2. Don't forget that I put a negative 14 in for this one. Now, if you think about it, negative 14 times the 1, which is our first term where it's 2 to the 0 power, is negative 14, and then negative 28, and so on. I didn't mean to go so fast, so I'll speak a little slower on this one. Notice that we're alternating negative, positive, negative, positive. And when that happens, you still need to start with a negative number in there. Now, this can get really confusing because if they don't start you out with a negative and then the negative is on the second one, that could be a little bit confusing. But I'm going to go ahead and put my first term here, and I'm alternating with my negatives. So what I'm going to do is I'm going to put in the number, which is 4, isn't it? I'm multiplying by 4, but I'm actually multiplying by -4. Do you see that -1 times -4 is +4? And then when I multiply by -4 again, I get -16. And my next term would be +64, wouldn't it? So I have a -1 out here, and I have a -4 as my multiplier or my geometric sequence. Okay, this one we're multiplying. Think about it, what you're multiplying by. That's going to be your multiplier, and that's what goes in here. That's your geometric increase. We're multiplying by 5 each time, and we're starting with 2. So we have 2, and we're multiplying by 5 powers of 5, as a matter of fact. It's a little easier when they're all positive. Oh, they gave us the same one again, 2 and 5. Thought maybe I made a mistake or something, but yeah, it's just 2 and 5. I guess they like that one. All right, now we're starting with 8, and be careful, it's not 8 times 8, it's 8 times 2, isn't it? And then 16 times 2. So our multiplier is 2, and our starting term is 8. Now, I could have probably just given you the instruction to start and without explaining why, but I like explaining. All right. We do need to start with -24, and notice that we multiplied by 3 this time, didn't we? But the problem is it's not 3, it's actually -3, and I multiply by -3 again. Now, that means that my multiplier is -3, or my exponential, the thing I'm taking to the exponent, and I'm starting with -24. Just remember that the reason why I have to start with a negative is because anything to the 0 power is +1, even if it's a negative number. So like -3 to the 0 power is +1. Anything to the 0 power is 1. So in this particular case, we're literally starting with the n-1, which is 1 minus 1. This is literally our first term. And since -3 to the 0 power is 1, it really gives us our -24. All right, hopefully it's clear as to why, because it could get you confused if they started with a positive, maybe. Anyway, there you have it. Looks good. Okay, again, we have a -1, and we're multiplying by -2 this time, and -2 again, and so on. So we start with -1, and our multiplier is -2, since we're alternating. This one is our multiplier is 4, and we're starting with 1. I guess they could have messed us up by changing this up, but I don't think they did. I don't think they're going to do it in this one. Maybe in the algebra 2. Starting term is 16, and you need to figure out what you're multiplying by. I hope you recognize these. We're multiplying by 2. One thing you want to memorize maybe is that sequence of 2 multipliers. See, if I start with 1 and then go to 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, you want to kind of memorize those because they're a very important progression when you double things. In this particular case, of course, we're starting with 16 and we're doubling. Oh, they gave us some decimals. Watch out. I did multiply this by 5, didn't I? I multiplied it by +5. And then I multiplied by +5 again. If you need to see that or how to find that, I guess you could grab a calculator and divide this term by this term. But it's easier if you can see that it's times 5. I guess that's better. But if you need to, you could grab your calculator and you have -0.6 divided by -0.12. Now, if for whatever reason you want to do this division without a calculator for, I don't know why you would want to do that, but some people may actually be interested in being able to do division without a calculator. So realize that the negatives are going to cancel out. And what I'm going to do is, in order to simplify this fraction, I'm going to multiply the numerator and denominator by negative 100. I didn't have to multiply by a negative. I could have just realized that the negative divided by negative is a positive. But I'm gonna be very, very kind of formal in this. I'm gonna multiply the top and bottom by negative 100. And look what happens. It moves the decimal 2 places and gives me positive 60 in the numerator. And in the denominator, I get positive 12. And 60 over 12 is 5. This is decimal division, but it's a little different way to look at decimal division. So anyway, that's what I did. Hopefully that's clear. You could have divided the negative 3 by the negative 0.6 in the same way and just multiplied by negative 10 in the numerator and denominator. Either way, my multiplier is 5. My first term is weird, negative 0.12. That's actually called negative 12 hundredths, and our multiplier is 5. All right, now it looks like we're multiplying by 5 again. If I had to guess, I'd say it's 5. You could check it. You could do the division. Some people are just going to grab their calculator and see. I'm going to go ahead and multiply 5 times 5, which happens to be the same as 0.11 times 25, which of course is 275 with 2 decimal places. And sure enough, there it is. Why did I do this? Well, multiplying by 11 you can do in your head. It's a little harder to multiply by 55. So what I did was I took this top term and called it 0.11 times 5 in my head and moved my multiplier to the bottom. I like playing with numbers, obviously. Anyway, it does work out. It is times 5. And of course, if you want to turn your brain off, just grab your calculator and divide this number by this one, or this number by this one, and you can find your multiplier. Notice that we're alternating negatives and positives. And this is the case where my first term is positive, and that can get you into trouble because remember, anything to the 0 power is positive 1. So for my multiplier, it's going to be negative 5. And for my original term, it's going to be 0.55. And that is going to work. So we've got 0.55. You probably don't need to put the 0. And negative 5 is my multiplier. Okay, we multiplied by 4. Hopefully you can recognize that that's just a 4 multiplier, just has a decimal with it. 0.4 is our first term, and 4 is our multiplier, and we're done. This time our first term is 1, and our multiplier is 4 again. We're multiplying by 4. I keep checking this just to make sure they don't mess with me. If they change that n-1, it can really mess you up because remember, you have to start with the first term when this piece is 0. So it could be a problem. I don't think they're going to do that, but you never know. Nah, they're probably not going to do that. Oh, now they change things up a little. They clearly divided by 4 here. But remember that we're really multiplying. So you really can't think of it as division. You have to think of it as multiplying by. Dividing by 4 is the same as multiplying by a fourth. So our multiplier is 1/4, isn't it? And you can see it clearly with the 67 times 1/4 is 67 over 4. Our first term is 268, of course. And a lot of people are going to get excited because they're going to say, oh, wait a minute, 1/4 to the 0 power can't be 1. It sure is. Remember, anything to the 0 power is 1. Anything at all, it doesn't matter. So it is 1/4. They didn't give me a fraction bar, so it looks good. Looks like I'm supposed to use fractions and so on. Okay, let's see what we got here. Times 4 again. Now, don't grab your calculator for this one, silly. Look, 5 times 4 is 20, and 0.03 times 4 is 12. See? See the 1200s? It's not that hard. You can do this. And our first term is 5.03. There's no sign changes or anything. And that is 4. And our multiplier is 4. You can do this. All right. Looks like we're doubling. Times 2, times 2, and our first term is -9. The signs aren't changing, so it's just a +2 in our multiplier. Oh, looks like we're multiplying by 1/3 this time. Hopefully that's clear, but take a look. Our signs are changing, so watch out. We're multiplying by -1/3, aren't we? Our first term is -152, and my multiplier is -1/3. Hopefully everything's clear on that. If you need to see it, just think about like this. This first term, when I put a 1 in for n, is -1/3 to the 0 power, which is equal to 1. And some of you may grab your calculator just to verify this. And I want to mention something. Watch out. If you put this in your calculator, it's going to tell you that that's a -1, and you're going to say, aha, Jimison doesn't know what he's talking about. Well, watch out. If you don't put the parentheses around this, it really is -1. But this is +1. And your calculator will mess you up. So watch out. Anyway, there it is. And it is alternating. And there we go. We're getting there. All right. This time we multiplied by, dang, what did we multiply by? It's not 7. It's 5, isn't it? Sure enough, it's 5. There's the 5, duh, times 5. Actually times -5. There it is. And we started with -2.8. Oh, and we have to find a term. I like this. Okay, so we do have to find our fourth term, which is going to be to the 3rd power. It's going to be this one right there. So I'm going to multiply by -5, of course, and that's going to give me +350. So that's going to go in my a to 4, and my a to the n. I'm going to start with my first term, which is -2.8. Nothing scary there. I've got a -5 as my multiplier, and I have a 350 for my fourth term. Hopefully all that's clear, and we're ready to go. Okay, what do we got next? Looks like we're multiplying by -3/5. Wow, think about it. 7/2 times what gives me -21/10. And yes, you could divide it, but remember, you'd have to divide it backwards. And people could get a little confused that way. Well, what did I multiply by? Well, 7 times -3 gives me my -21. That's where I got that. And 2 times 5 gives me my 10. Remember, fractions work when you multiply them just straight across, just like you'd wish addition worked, but it doesn't. Anyway, there it is. Our multiplier is right there. And it looks like our first term is 7/2. You could write 3.5, but 7/2 is fine. And we have a -3/5 for our multiplier. And it's going to alternate back and forth. Notice that my first term is positive, so my first term is positive. And I want the fourth term, so I'm going to have to multiply this by -3/5. So multiplying -3 times 63 is -189. And 5 times 50 is 250. Now, one question is, can you reduce this? And 63 has the factors 7 times 9, which is really 7 times 3 times 3. Now 50 has the factors 2 times 5 times 5. So we can see there's no common factors in here. And when I multiply by -3/5, there's still no common factors. We say that these two numbers, even though neither one of them is a prime, we call them relatively prime because they have no factors in common, and there is no way to reduce that fraction. So don't worry, it's -189 over 250. Not so scary. It's okay. You can do this. Oh, they're gonna really make us work for this one. All right. So we multiplied by -5, didn't we? Put the negative in there. Dang, didn't work. Okay, so times -5 again. And our multiplier is -5. Our first term is -7. -5 is our multiplier. And they want to know what is the next term. So we're going to have to multiply by -5. So I'm going to take a -175 and I'm going to multiply it by -5. And I'll just go ahead and multiply it out. 5, carry the 2, and that's going to be 37. Carry the 3, and that's going to be 875, isn't it? And it is a positive because a negative times a negative is a positive. And it looks good, doesn't it? Yeah, why not? 875. And you could grab a calculator. No, you couldn't. You don't want to grab a calculator. You don't want that calculator. Put it down. It's dangerous. All right, our first term is 1. We're multiplying by 4. Multiplying by 4. 4 is our multiplier. 1 is our first term. 4 is our multiplier. And we want the next one, which you better know is 64. 16 times 4 is 64. That's 4 to the third power. It's one of those that you want to memorize. And a lot of people say, well, how can that be? Because I know 8 squared is 64. Well, it also happens to be 2 to the 6th is 64. And there's a lot of stuff going on with these exponents. And these are some things you want to memorize, some of your powers, because when we get to exponents, it's going to be very useful for you to understand what's really happening. A lot of people are going to say, well, wait a minute, I don't want to memorize anything. Well, it's not that hard. And so that's 64 anyway. There it is. And it is the fourth term. Yeah. All right, we're going. Okay, we multiplied by 2, multiplied by 2. Our first term is 14, no sign problems. And the fourth term, of course, is 112, isn't it? We multiply by 2. Looks good. Looks like we multiplied by 2, multiplied by 2. Oh, this time we want the seventh term. Be careful. Now, I could do it directly, and I guess I'll show you how to do it directly, just in case you ever want to do it, because you don't want to have to multiply each time. I'll do it both ways, though. So our first term is 3, our multiplier is 2, and I'll show you both ways to get a to the 7th. A seventh, the seventh term, we find our first term is 3, and our multiplier is 2. So we're going to take 3 times 2 and n minus 1. In this case, it's 7. So we're going to take it to the 6th power. And like I said before, 2 to the 6th power is 64, isn't it? And then we're going to multiply that by 3. Now, a lot of people are going to grab their calculator maybe and do 3 times 2 and accidentally hit the equal sign and then take it to the 6th power. And you're going to get something like 8,000 or something, or 80,000. You don't want to do that. No. Because remember, exponents come first. 2 to the 6th power is 64, which is going to be 192, and you're done. Now you could have done the times 2, and so on. So it's going to be 24, 48, 96, 192, isn't it? And there's 1, 2, 3, 4, 5, 6, 7. Yeah, you could have done it that way too, but I think that this is probably better for you. So 192, and looks like we're done there. Okay, it looks like we're multiplying by, that's odd. What did we do? Okay, we divided this one by 2, but we also multiplied the bottom by 2, which means we're really multiplying by 1/4. Here, we can see it here better. I was looking at the top and I was thinking, geez, what's going on? We're doing something with 2 from the numerators, and then we're doing something with 2 in the denominators. But it's clearer for this pair here that we multiplied by 1/4. What happened with the first pair is that we multiplied by 1/4, but then we had to do some simplifying. You see why it kind of messes you up. So be a little careful here. We did multiply by 1/4. That is our multiplier. That's our multiplier. Our first term is 706 over 3, no reducing, of course. How do I know that 3 doesn't go into 706? Well, you could grab your calculator and divide it, or you could add the digits. By digits, I mean the actual numbers that appear here, here, and here. If you add 7 plus 0 plus 6, you get 13. And 3 does go into 13 4 times with a 1 remainder. So what happens is if I divide 3 into 706, I also get a 1 remainder. This is called number sense. This is how you can determine whether something is divisible. It's called a divisibility rule. And it tells you that 706 is not divisible by 3. And 3 is not a factor. It also tells you the remainder is equal to 1 when you divide it. So if I divided 3 into 706, it would give me a 1 remainder, and I'd have something with a 1/3 at the end. Anyway, lots of stuff going on there. The 1/4 is my multiplier, and I know you want to get done. I want the 5th term, so it looks like I'm going to have to multiply by 1/4 a couple more times. So I've got 353 over 24, and I need to multiply that by 1/4, and that's going to give me 353. Clearly, 353 has no even numbers in it, and it's also not divisible by 3 because our original 706 isn't divisible by 3, so neither is the 353. We're multiplying 24 times 4, which is 96. And then we're going to multiply by 1/4 again, which is going to give us 88? That's 353 over, no, it's 384. Sorry, can't, 86. God, I can't multiply today. No, 384. God, my brain isn't working real well. I'm trying to subtract 16 without having a major problem here. Anyway, it's 96 times 4 is 384. What I did was I took the 100 minus 4 and multiplied by the 4, which gives me 400 minus 16. The problem was the 4 was messing me up, but it's 384 because you take 16 away from 400 and you get the 384. So we have 353 over 384. And I don't see any errors, no negatives, looks good. And we got a couple more, let's see. Oh, an easy one. We multiplied by 5 and we multiplied by 5. We started with 2 and our 5 is our multiplier, and they only want the 4th one, which is 250. This looks familiar. I think they gave us this one before. And our last one, and then we're done. I hope you guys will try these yourself. Oh, they gave us a nice easy one. Our first term is 1. Our multiplier is 3, no negative problems, and they want the 6th term. So it's 27. What's the next one? I hope you know it's 81. And do we need another one? 1, 2, 3, 4, 5. Nope, 81. Oh, 6th term. 243. There's our sixth term. And I hope you guys will try it yourself. And I'll see you back again. Bye. There it is.